Hey class, this is Mr. Lee. Welcome to my YouTube channel, or you're probably watching this on Learn. Either way, welcome. We are going to finish up the last section of Chapter 4. So let's get ready for our Cornell notes. So let's draw a line right down the middle, right up here. Alright, so today's objective, SWBAT. Students will be able to use GCF to simplify rational numbers. Now, a lot of people are asking what GCF is, so let's write GCF. This is our first vocab word. GCF is greatest common factor. Greatest common factor. Greatest common factor. Alright, so our GCF, our greatest common factor. Well, what's the greatest common factor? Or what is even a factor? Well, a factor means a piece of something. So look at this. I'm going to use this number. I'm going to use the number 12. The number 12. What times what will get me 12? Well, let's branch this off. I know 2 times 6 gets me 12, and 3 times 4 gets me 12. Each little piece that times all these guys, all these arrows are pointing to, these are called factors, okay? So a factor is just a fancy word for a piece of something. A piece of a number. So what does greatest common factor mean? Well, greatest common factor means the biggest piece that matches with another piece. So greatest means big, common means it shares something alike, and the factor is a piece. Now, here's what we're going to do. We're going to try to find the GCF. And the whole reason that we need to find GCF is it's going to make simplifying numbers like this, it's going to make this way easy. Instead of just saying, oh, I know my 25 times tables, we're going to use the GCF to figure out what we can divide with. Alright, so let's look at some numbers now. Let's look at the numbers 30 and the numbers 12. And this is our first example, 30 and 12. So let's figure out what times what will get us the number 30. Well, let's, 1 times 30 will get me 30. I know the number 2 times the number 15 can get me 30. The number 5 times 6 can get me 30. And the number 3 times 10 can get me 30. Alright, let's do the number 12. We do 1, and we know 12. We know the number 2 times 6, and we know the numbers 3 times 4. Alright, so these are all the factors of 30. These are all the factors of 12. What do they have in common? What they have in common is 1, that's obvious. They have the number 2. They have the number 3. And they also have the number 6. So these are common factors. But what's the biggest or greatest? What's the greatest factor that they have? Well, the biggest number is 6, so the greatest is 6. So if we ever have a fraction, 12 over 30, instead of dividing it all the time, we can say 12 divided by 6 and 30 divided by 6. That's going to get us 12 divided by 6 is 2, and 30 divided by 6 is 5. Alright, so we just did 30 and 12. Let's try 10 and 32. 10 and 32. So we're going to find the greatest common factors. But our first step is we need to find out what times what will get us 10. 1 times 10, 2 times 5. And I think that's all. Alright, now let's try 32. We can go 1 and 32, 2 and 16, 4 times 8 will get me 32. So let's circle what they have in common. There is 1, 2, it looks like that's it. So what they have in common is 1 and 2. But what's the biggest one? The greatest has to be 2. So if we ever have a fraction, 10 over 32, we can just divide it by 2 because the greatest common factor is 2. We can't use 1. 1 would be useless because if we divide 10 by 1, that would be 10. And 32 divided by 1 would be 32. And that doesn't do any good for reducing. 10 divided by 2 will get us the 5, and 32 divided by 2 will get us an 8. Alright, this listing technique is good, but it's kind of long. Let's try out a different trick then. What we're going to do to find the GCF, this is called a factor tree. So we're going to do a factor tree. Because of how my camera's set up, I'm turning to the fresh, clean page. But if you have enough room right here, right on the back of this page. Again, I'm just doing this because my camera doesn't give me enough room. So right now, this is called a factor tree. And this is our main technique. And the factor tree is for GCF. GCF. We're going to find the GCF for the numbers 20 and the number 24. So what I'm going to do with the number 20, what times what will get me 20? Well, I know 5 times 4. I wrote down this little branch and broke down into this. So I got 5 times 4. Next, I have to break down the 4. So it's 2 times 2. And I still have to drag down the 5. So all the factors are 5, 2, and 2. Next thing, I'm going to do the same thing for the number 24. So what times what will get me 24? I know 4 times 6. 4 times 6 will get me 24. Next, I'm going to break down the 4. What times what will get me 4? 2 times 2. 2 times 2. And what gets me 6? If you said 2 times 3, you're right. Alright, now let's circle what they have in common. Well, I know for this, there's a 2 here and a 2 here. So I'm going to write down, this is called common. So they've got 2. They also have another 2 and another 2 right here. So it's 2 times 2. Notice I can't use this 2 right here. Why? Why can't I use this guy right here? The reason I can't use this 2 right here is because there's no 2 matching for it over here. It's missing. So the only common factors that I have, 2 times 2 is 4. So the GCF is 4 for the number 20 and 24. Why do we need to do this? Because if we have a fraction 20 over 24, the GCF now we could divide it by 4. So that's going to give us 20 divided by 4 is 5. 24 divided by 4 gets us 6. Alright. If you're watching this at home by yourself, please write down the following example, pause it, and then see if you can beat me to the punch. We're going to do the number 52 and 200. 52 and 200. I know for 52, it's 13 times 4. 13 times 4. I can break down the number 4 into 2 times 2. Now for the number 200, I can break it down as 10 times 20. Alright, pause it right here and try to break down 10 and 20. Welcome back. So, what did 10 break down into? That's 2 times 5. And 20, if you got 4 times 5, that's also good. I'd also accept 2 times 10. So, we're still got to drag down our leftovers. So this is 2, this is 5. 4 breaks down into 2 times 2. And we still have a leftover 5. So let's circle what they have in common. What do they have in common? Well, there's a 2 right here. So I'll put down a 2. And there's a 2 right here. So it's 2 times 2. This 2 matches this 2. This 2 matches this 2. Again, I can't use this leftover 2 right here because there's no 2 right here. So the GCF is 4. Alright, now I want you guys to do on your own this number. Can you find the GCF of 72 and 180? 72 and 180. Pause it right here and try it on your own and then check your answer. Welcome back. Let's try to do 72. Now, the way I'm going to look at 72, there's a lot of different ways to look at 72. I'm going to do 9 times 8. 9 times 8. So this breaks down into 3 times 3 and 4 times 2. So I can break down 4 into 2 times 2 and drag down my leftovers. So I have 3 times 3 times 2 times 2. Next, I have 180. And I know that's 18 times 10. So I can do 2 times 9 and 2 times 5. So next, we could do 3 times 3. And we could do 2. Let's drag this down. This also becomes a 2, and that's a 5. Now let's write down what they have in common. Okay, there's a 3 right here, and it matches this 3. There's also a 3 right here, and it matches this 3. So right now I have 3 times 3. Okay, this 3 matches that 3, this 3 matches that 3. I also have a 2, and it matches this 2. So I can write down times 2. I also have one more 2 right here, and I could write a 2 right there. Alright, Do I have any leftover 2's for this guy? No. There's a 5 here. Is there a 5 over here? No. So let's find our GCF. The way that we're going to do this is multiply it. 3 times 3, well, that gets me 9. 9 times 2 times 2, 9 times, let's see, 2 times 2, well, that gets me a 4. 9 times 4 is 36. So now if I ever get a really ugly fraction, like 72 over 180, I could divide this guy by 36. 72 divided by 36, well, that's a really big number. So what I'll have to do then is put it in the division house. Well, I gotta say that that looks like 36 goes into 72 2 times, because 2 times 6 is 12, carry the 1, 2 times 3 is 6 plus 1, that's 72. So I know this becomes 2. 180 divided by 36, that has to become 5.